FS 3128, Topic 10, Class 2, where we start to actually use calculus for something. A little bit further into Class 2, you will see why we need to find a second derivative, but at the moment we're just going to look at what the second derivative or more is. If you can differentiate, in most cases you can just differentiate again, and a lot of notations can be used just as they could for the first derivative. So we'd use two dashes, or we'd write it d squared y dx squared. For example, let's have a look at the first one here. We could find f dash, so that's the first derivative, so it would be 6x squared minus 10x plus 6, and then we could find the second derivative as being 2 6's are 12x minus 10, and so on. Not page 414, but exercise 33.4 will give you some practice at finding second derivatives. Also MyMathLab higher derivatives. Now, a lot of students get the idea that calculus is all about graphs. It's not. Finding maximums and minimums of functions is just easier if we look at the picture and then we can see what we've got. But it is certainly not about finding them on a graph. It's about finding the maximum value of a function or finding the minimum value of a function. It just happens that we can see things better than we can think, so putting it on a graph is helpful. Now if we look at this graph, you can see, as the labelling says, that there's a maximum at A, a minimum at C, and what we call points of inflection at B and D. Here the curvature changes. And it goes from being concave to being convex. So both B and D are points of inflection. The curvature is changing at those points. Now we can use calculus to find A and C. We can also use it to find B as well. B and D aren't particularly in this course, though we will have a quick look at them. Let's break this down. Let's have a look at a minimum point. For a minimum point, at the bottom, the slope of that line is 0. And similarly, for a maximum shape point, the slope is equal to 0. Now have a look at a minimum type shape. On the left of that, we've got the slope is negative. Remember back for whichever topic it was before, we've got a negative slope, and on the right of it we've got a positive slope. For a maximum shape, we've got a positive slope coming up, briefly a 0 slope, and then a negative slope. And for a point of inflection, we've got a positive slope, a 0 slope, and then a positive slope again, or a negative slope, a 0 slope, and a negative slope again. Now, we've got a couple of tests that we could use so that we don't have to draw the graph. Because this tells us, the derivative tells us the slope, then we can use the idea that it's telling us the slope to say that if we've got a maximum point like that, to the left of it the slope is positive, and to the right of it the slope is negative. So all we'd have to do is find the point where the slope is 0 there, and the derivative is positive to the left, and to the right it's negative. And similarly for a minimum type point, the derivative is 0 at the bottom, and the derivative is negative to the left and positive to the right. So the first step to do this question, to find the maximum or the minimum of this function, would be to find where the derivative is equal to 0. So we need to find the derivative. So the derivative would be 6x squared minus 12x minus 18, and we want that to be equal to 0 because that's at the turning point. We could divide it by 6, and we could solve it either using factorising or the formula, and it would tell us that x was equal to 3 or x was equal to -1. And we would also need to find that when x is 3, y is 54. We're just going to put it back into the original. And when x is -1, y is equal to 10. Now we can see from that y equals 54 is bigger than y equals 10. So we can see that at x equals 3, it must be the maximum. And no, actually, that's -54. So that this is the minimum and that this is the maximum, but we need to prove it. Okay, what we're going to do is we're going to take x equals 3 to start off with, and we're going to look at the derivative to the left of 3. So we're going to choose, say, 2.9. We're going to put 2.9 into the derivative, and we will find that we've got a negative number if we're to the left. And if we're going to choose a number such as 3.1 and put that into the derivative, we find that the result is positive. So what that tells us is that there's a minimum value of y at the point where x is 3. And let's look at x equals -1. Let's look to the left first. Okay, so to the left, now this is where we have to be a little bit careful. To the left of -1 would be, say, -1.1. Put that in to the derivative function and we find out that it is positive. And if we go a little to the right of x equals -1, say x equals -0.9, and put that into the derivative, then we find that the derivative is negative. So that tells us then that there's a maximum at that point. So at -1, 10, there's a maximum, which is what we knew, but we needed to prove it. Now this might be the relationship of something to something else, but at this stage let's just look at it as being a graph. Here's the graph showing that information. It's got a minimum at x equals 3 and a maximum at x equals -1. Let's do this one in class. This is the result of the previous slide that we did in class. However, we can encapsulate that in one single test, because sometimes it gets a bit tricky. You've got to do lots of calculations and sometimes you make a numerical mistake and then the whole thing's wrong. So what we can say is that we can use the second derivative test, which is why we needed to find the second derivative, and we can say, well, okay, if the first derivative is 0 and the second derivative is positive, then we have a minimum point. If the derivative is 0 and the second derivative is negative, then we have a maximum. So it's like that. And if the first derivative is 0 and the second derivative is 0, we have a point of inflection, like that. So now we only have to do one test. So we would start with our function. We would find the derivative. And then we would find the x values where that is 0, because it's 0 for the max or min. And that tells us that x is equal to -4 or 3. And we need to find the y values. Just using a calculator. Now we need to find the second derivative. The second derivative is going to be 2x plus 1. So now we have to find the value of the second derivative when x equals -4. So then the second derivative if we put in -4, the second derivative is going to be negative. So that means there's a maximum when x is -4. And when x is 3, we put x equals 3 into the second derivative. And we see that it's going to be positive. So there is a minimum when x equals 3. And some work for you to do. Exercise 33.5, My Math Lab, and you can make a start on assignment 10.